Hi, this is Fear, and for my NYP personal project, I'm going to be going over what machine learning is in simple terms, not only to deepen my own understanding, but to give knowledge to those who wish to learn on this topic. Now, by definition, machine learning, or ML for short, is a study of computer algorithms that improve automatically through experience. Machine learning is one method of achieving artificial intelligence. Now, ML, or machine learning, allows computers to learn from data given to them. Now, using this knowledge, it can make predictions, which is known as extrapolation. The process of machine learning is as follows. We first must obtain a large amount of training data. Then we are going to create or choose an algorithm. Then we train the algorithm with the data given, and validation can also be done. Then we test the algorithm on new data, which it hasn't seen before. So let's say, for example, we want to make an algorithm that can detect the difference between apples and bananas. We collect 50,000 images of both fruits. 25,000 are apples and 25,000 are bananas. We feed this to the algorithm, and using our form of gradient descent or cost system, we are able to decipher a pattern in the data, which the algorithm does. And now, using this pattern, we can train or test the algorithm on new data and make predictions. So when we give it these many pictures of apples and bananas, it will learn the difference between the two, and it will be able to predict, given an image of each fruit, it will be able to tell you if it is an apple or banana. Now, I'm going to be going over some other important information. Now, in machine learning, we have something called features, which are factors which affect an output. These are our inputs or x values. Then we have our outputs or y values, which are known as labels. We also have weights, which are multiplied on our x values or features. Now, on the right, you will see a more detailed explanation or something that connects to a real life scenario. So, let's say that our machine learning problem is given someone's years of work experience, we can predict their salary. So, our feature, we only have one feature in this case, this will be the years that they've been in the workforce, and our label or output will be the salary. Now, I'm going to be going over one of the most simple machine learning algorithms, which is linear regression. And this is essentially just a line of best fit, which you learn in Algebra 1. Now, what this does, it finds the best line possible after moving slightly for every iteration. This finds the distance from the data points, which is known as the error or cost, then plots the most effective line. Now, on the bottom corner, we have y equals mx, which can be a sample equation for our line. Now, y is our label or output, which is salary. X is our input or feature, which is years of experience, and M is our singular weight. It's what gets multiplied on our X value and gives us a prediction. So this is what the weight is being trained on. So when we train our algorithm or make it learn, it's essentially learning this M value, this weight. Now, the next image will go in depth on showing you what this M value actually is and how it can be changed and trained on. Now, let's say that we have the same scenario where X is our years of work experience and Y is our salary. Now, the red line is our machine learning model, which is linear regression. The blue points is our data set, so all the data that we're given. And now we connect the blue points to the red line. This is the distance that, or error, which is also known as cost, of our model. Now, let's say that our cost is all positive in 10. That means, for example, that means all of our points must lie up here. If our total cost is, let's say, negative 10, that means all of our points lie below the line. But obviously, in this case, we have different values. So let's say we have 2 here, then we have minus 3, 1, 3, things like that. So we have different values. Now, machine learning will never be perfect, but we want to get it to the closest possible value or the least cost or the smallest error so we can have the line of best fit. Now, let's say that we've trained our line effectively and we have an effective linear regression model. The next step is to extrapolate so we can predict new data. So given years of experience, we want to predict our salary. So let's say that we're given a value of 12. So our data set clearly doesn't have 12 right now, but as we know, we can extrapolate because given 12, we have our model. We'll just go to 12, move up to the line, and wherever we see that, we'll match it to a y value on the side. And just for time's sake, we won't actually do this, but we can see that given, let's say, a years of experience of 12, it would be somewhere over 120,000 because obviously 10 is reached there and 12 would be more than that. I'm now going to go over a very common use case of machine learning, which is image classification. So, as I said in the beginning, an example of this was given an image of an apple or a banana, tell which of the two fruits it is. Now, I'm going to be going over how this actually works in machine learning. So first of all, what are the features? Now, features in image classification are RGB values of each pixel. So usually when we have machine learning, we don't want to have a very high quality image because that's unnecessary for the computer to take in and it will take a lot of computing power. So let's say we have a 32 by 32 image with 124 pixels. Now each of these 1024 pixels has RGB values, so three numbers for each pixel, one for red, green, and blue. Now 1024 times 3 is 3072. So this is the amount of features we have for one total image. Now, this is where the dimensionality comes in. So, this is where things like programming languages like Python and a library like NumPy would be very useful because we can use these dimensionality arrays to give our X data. Now, our label for image classification is just going to be the class of the image. So, let's say we're finding the difference between car, shoes, trucks, and shirts, things like that. So, obviously, we would know that this image is a car, but as we know, the computer doesn't know that, and we'll have to make an algorithm and train it on this so the computer will eventually learn. Now we're going to be going over the significance of machine learning. First of all, it's a means of artificial intelligence. Second of all, it's a completely different approach to computer science. We don't have to hard code anything. So I'll go back to the previous image. We don't have to say if pixel is white, it's a car. We have an algorithm that will give us patterns itself when we train the data. Another great part about machine learning is that there's many different use cases. Some examples include the prediction of an election or speech recognition like Siri or Google Home. We can also have traffic light prediction, which can be used for autonomous cars. So when a red light turns red or turns green, it will notify the driver, oh, you should probably move. We can also use machine learning, especially linear regression, for stock price prediction, which again is very useful. That concludes my video on what machine learning was in simple terms, and I hope everyone learned something. Thank you for